there, friends. We're friends. You're my friend. You're right, I don't have any friends, really. I was looking for some friends, and they all left me. That's because I sit in my basement and record videos all day long. Anyway, all of this stuff can be found at www.nkinfinity.com. Can you do me a favor? Tweet it out, text it out, let your friends know, let your colleagues know, let anybody else know. You know, check us out. I'm doing 7 videos tonight, I think. We're going to have a bunch of videos and new stuff coming every day. I'm going to be reviewing the live streaming. Hasn't really been working very well, so sorry about that. Okay, I want to get going, but please hit the subscribe button. Tweet it out, text out the website, my name, our username on YouTube, the YouTube channel, and let's see if we can get my subscribership up as much as possible, because that way I get some better commercials, so you don't have to watch bad commercials. And I apologize about the commercials, but they do pay for my new computer maybe someday, and maybe if I do this for 5 years I can get a new one. Anyway, let's get started. The word proof, as defined by Mr. Krause's dictionary, says, stop messing with both sides. You're only allowed to play around with one side. That's what it says, really. If you look it up in the dictionary, it's what it says. So mess with one side only. Mess with only one side. Now, before we start working on trig functions and proofs, we ought to probably go through a couple of these. You need to remember that cosecant of theta is 1 over sine theta. You need to remember that secant of theta is equal to 1 over cosine of theta. Have you gotten the flashcards yet? I would highly recommend you get the flashcards, children. You need to know that tangent of x is equal to sine x over cosine x. And cotangent of x is equal to cosine x over sine x. I could have made these boxes a little bit smaller. You need to know that sine squared x plus cosine squared x equals uno. You need to know, and these are the hard ones, tangent squared x plus 1 is equal to secant squared x. And that, let me try to do this one on the side. Cotangent squared x plus 1 is equal to cosecant squared x. You need to know all those. Those are in your flashcards. You need to know them. All right. So, let's see what we got. Whoa, holy crud. Stop. All right, let's move. Let's work through this. So, you need to only mess with one side. Whenever it says show or prove, you can only mess with the one side. I always usually take the more complicated side. So maybe what I want to do is just factor this and see if I can factor it. M times m is m squared. P times p is p squared. And if I put a plus and a plus, this gives me mp, and this gives me mp, which is 2mp. So this is really just equal to m plus p squared. Well, that wasn't too difficult. Now, if you wanted to, you could have started with this side, double distribute this side. This one, it didn't really matter which way you went, and then do it m squared plus mp plus mp plus p squared, and then write it as m squared plus 2mp plus p squared equals, and then bring this down. Either way would be acceptable. It doesn't matter. What the? Using sine squared plus cosine squared equals 1. Show that tangent squared plus 1 is equal to secant squared. Oh, this is that stupid question. I don't even like this question. But whatever, let's do it. Sine squared plus cosine squared equals 1. I should say x equals 1. Well, how do I get tangent squared? The only way to get tangent squared, if you remember from up here, tangent is sine over cosine. So the only way to get tangent squared is to divide by cosine squared. But if I divide this by cosine squared, I got to divide this by cosine squared, and I got to divide this by cosine squared. Okay? Well, if that's true, this is tangent squared x plus 1 equals, now 1 over cosine is secant, so this is secant squared x. That's all there is to that problem. Oh my goodness. So there's, algebraically determine the values of C and B. Yeah, there's a problem like this on an old Regents, and like half the kids just quit. Okay, the first thing you should probably do is just start distributing, right? So I'm going to just write this. I'm going to write this equals here, and I'm going to distribute this out. X times this is 3x cubed. Here, let me try to do it a little bit smaller. I'm going to pick a different pen that's smaller. 3x cubed. And then x times bx is minus bx squared. And then x times 5 is plus 5x. And then negative 2 times this is negative 6x squared. And this times this is positive 2 bx. And then this one times this is minus 10 plus c. Now, I think I can combine a few things. So I get 3x squared. No, I can't combine anything. But this is supposed to be equal, apparently, to 3x cubed minus 13x squared plus 19x minus 18. Now, it didn't say prove. It just said it wants you to algebraically determine the values of b and c. Well, the first thing I'm going to do is get rid of these. Because if I subtract them and move them over, they leave. So what I end up now is negative, let's clean this up, negative 13x squared plus 19x minus 18 equals negative bx squared minus 6x squared plus 5x plus 2bx minus 10 plus c. Holy crap. So, at this point, I've cleaned everything up. I've moved everything around. Hopefully, I haven't made a mistake. These are all my x terms, x squared terms. Well, they have to match that thing. So I know all the x squareds have to be the same. Somehow I have to have negative 13x squared over here. So I'm going to do, okay, negative 13x squared has to equal negative bx squared minus 6x squared. All right, well, okay, let me solve for b. Bring the 6x squared by adding 6x squared. So I get negative 7x squared equals negative b x squared. Well, now what I'm going to do, I know this seems a little bit weird, I'm going to divide by negative x squared. Divide by negative x squared. Well, the x squareds cancel, the negatives cancel, the negatives cancel, the x squareds cancel, and I end up with b equals 7. Now, I'm going to check that. The cool thing is I can check that because look at this. Let's do this in blue. These two are the x terms, and they got to come up with 19x. Let's see if that works. 5x plus 2 times 7x. Does that equal 19x? Well, this is 5 plus 14x. 19x equals 19x. Now, finally, we're going to circle this in green. This is all the constant stuff, and that's got to equal negative 18. So, negative 10 plus c has to equal negative 18. Add 10 to both sides, and I get c equals negative 8. So there's my answers, kids. b equals 7, c equals negative 8. And then this one. All right. I'll take a break and I'll be right back. 8 minutes, oh my gosh. So I kind of noticed that the problem that was up was not workable. I looked at it real quick and I'm like, that one's not going to probably be doable. I don't think it is, so I didn't bother with it. Anyway, this was the one that was supposed to be here, so I switched it out. Always start, now if it's approved, you can only mess with one side and start with the more complicated side. We're going to mess with this side. Now if you look in the numerator, don't they have a GCF? The answer is yes. So I can take the GCF out, cosine theta, times sine theta plus 1, don't forget, all over cosine squared theta. All right, so that's cool, because then I can cancel one of these with this. So don't mess with this side. It still says tangent theta plus secant theta. So what do I got here? I really have sine theta plus 1 over cosine theta. Well, I can split the numerator up, and this is the hard part for most kids to understand. I'm kind of running out of room because I wrote so big. This is going to be sine of theta over cosine of theta plus 1 over cosine of theta. Now, if I was to add these two up, don't they just need to have a common denominator? In order to add them up, they have to have a common denominator. Do they? Yeah, they still have cosine theta as their common denominator. So I can just add them up and add the numerators. And that's why this, wherever my mouse pointer is equivalent to this. Well, isn't this right here tangent theta? Yep. And isn't this right here secant theta? So you do have to write this last step. Tangent theta plus secant theta is equal to tangent theta plus secant theta. I'll try to write smaller on the next one. Oh my gosh. Algebraically prove. Okay, so there's probably no way you're going to turn this into this. So we're going to take this and turn it into this. So we're going to say, okay, x plus y times x plus y times x plus y. And we're going to do these first two. So I'm going to leave this one around for the ride. And this is going to be x squared. xy and xy is plus 2xy plus y squared. Now I'm going to distribute the next one. So x times x squared is x cubed. X times 2xy is plus 2x squared y. And x times y squared is plus x y squared. Now I'm going to distribute the y. Y times x squared is, I always put the variables first. I always put the variables in alphabetical order. So this would be x squared y plus 2xy squared plus y cubed. I'm almost done. Combine like terms. I get x squared. Now this and this are both x squareds y, so that's plus 3x squared y. Now I can put this together with this, so that's plus 3xy squared plus y cubed. And that, of course, equals x cubed plus 3x squared plus y, or y plus 3xy squared plus y cubed. There it is. That's the proof. Oh, this one was just on an old Regents. This one you've already done before. I'm sure you've already done this. I think it was on the June 16 region, but whatever. I guess we got, so mess with one side. So in order to mess with this side, I have to have a common denominator. Well, this one is already 1 over x cubed plus 8. So this one has to be x cubed plus 8 over x cubed plus 8. Because doesn't that equal 1? Sure it does. And now that I have a common denominator here, all I got to do is add up the numerators. So x cubed plus 9 over x cubed plus 8. Does that equal x cubed plus 9 over x cubed plus 8? Now what the hell does this mean? All this means is you can't use negative 2. Because if you were to plug in negative 2, what is negative 2 cubed? Negative 2 cubed is negative 8, and that would cause the denominator to be undefined. Can't have it. Holy crap. Here's one of these again. Algebraically determine. All right, so let's start with, we're going to just keep this 2x cubed minus 10x squared plus 11x minus 7 on this side. And over here, we're going to distribute. So x times 2x squared is 2x cubed. Now, immediately, don't those cancel? Those are going to cancel. Got the same thing on both sides. They're definitely going to cancel. X times hx is plus hx squared. And x times 3 is plus 3x. Now I'm going to do negative 4 times this is negative 8x squared. Negative 4 times this is negative 4hx. Negative 4 times 3 is negative 12 plus k. Oh. Okay, I'm back. That's all I needed. All right, so here we go. This is what we got. We got x squareds here, and we got an x squared here, and an x squared here. So those have to equal each other. So set them equal to each other. Negative 10x squared has to equal hx x squared minus 8x squared. Add the 8x squared over, and I get negative 2x squared equals hx squared. So doesn't h just have to be negative 2? I mean, right? Doesn't it have to be negative 2? The answer is yes. Thank you very much. Let's do the blues. 11x, oops, and here's an x term, and here's an x term. So those have to be equal to each other. So I know 11x has to equal 3x minus 4hx. Well, wait a second. I already figured out what h is. That's negative 2. So does 11x equal 3x minus 4 times negative 2 times x? This is just 8. And 8x and 3x is 11x. Yay! Finally, we want to make sure our constant, negative 7, is equal to this stuff over here, which is what I think, if I'm not mistaken, let me get rid of that, negative 12 plus k. So, negative 7 has to equal negative 12 plus k. Bring the 12 over, and I get net k equals 5. All right, kiddies, this one, not so intuitive. This one's going to be a little bit tough. Not going to lie. If you can get this one right, you're a beast. So if you could try it on your own. Press save. Go ahead, try it on your own. I dare you. I'm going to be up all night. Let's distribute. Cosine squared plus cosine theta plus sine squared theta equals that mess. Well, these two together, cosine squared plus sine squared, is really just 1. So what I end up with is 1 plus cosine theta equals sine theta plus tangent theta over tangent theta. I'm not even close. I'm not even close to getting there. So I got to come up with a strategy. Remember, you're only allowed to mess with this side. I can't change this side. I could start messing with this side to try to make it look like the left side, but then I'll lose credit. My goal is to try to make this look like that side somehow. Well, do you notice that it has tangent on the denominator? So what I'm going to do is I'm going to multiply the left side by 1. Now, if I just put a 1 there and I multiplied it, that'd be kind of stupid. So I don't want to do that. Now, this is you probably wouldn't have guessed this thing to do. I'm going to multiply this by tangent theta over tangent theta. That's 1, isn't it? Sure. So I get tangent theta times 1 plus cosine theta all over tangent theta. Well, if I distribute, I get tangent theta plus tangent theta cosine theta all over tangent theta. Well, okay, I'm almost there. What is this? Well, isn't tangent theta cosine theta, really what I have here is tangent theta plus sine theta over cosine theta times cosine theta over 1 all over tangent theta. Now these cancel, and I end up with tangent theta plus sine theta all over tangent theta, which is in fact equivalent to sine theta plus tangent theta over tangent theta. Holy crap, that was a beast. Let's check this one out. Again, the left side's more complicated, so let's mess with the left side. All right, I'm completely baffled. I should have probably made an answer key before I did this. This is doable, but ain't nobody ever going to figure this one out. All right? Nobody's going to figure this one out. All right, so let's just do it anyway. So in the numerator, if I double distribute this, this gives me cosine theta plus sine theta. And I double distribute it. I was just trying to figure out, there's an old way to do this. I can't do it the old way because it's not in the new curriculum. Plus 2 sine theta cosine theta. Sine theta cosine theta plus sine squared theta, all over 1 plus 2 sine theta cosine theta equals. Well, don't these make 1? So really what I end up with the numerator is 1 minus 2 1 plus 2 sine theta cosine theta, all over 1 plus 2 sine theta cosine theta. Well, that's just 1. So what I really got is 1 equals cosine theta tangent theta cosecant theta. Now, off to the side here, cosine theta over 1 times times sine theta over 1 over sine theta over cosine theta times 1 over sine theta. That's what this is, right? That's what each of these pieces are, right? The sines cancel, the cosines cancel. I end up with 1 equals 1, but you can't do that. So the only way to solve this is to multiply this side by 1 by saying we're going to multiply by cosine theta, tangent theta, cosecant theta, which is really just 1. It's dumb. You would never have gotten this. Nobody would ever get this. Cosine theta, except a math teacher. So don't do it. Don't think you had to get that one. If you were beast mode and you got that one, great. If not, I'll tell you what. I can't stand these. I'm going to go find some other ones, some simpler proofs, and try to throw those in a document for you. I'll do those over the next couple of weeks, and I'll put something better up for you, okay? So that wasn't a great problem. Sorry about that. Catch y'all on the flip.